Okay, so let's implement the SARSA. So first import gem, put numpy, np. Okay, so we are done with importation part. Let's create the environment. Okay, so it will be env equal to gem dot make frozen lake version 1. Okay, now we have all the parameters. Okay, alpha equal to 0.1, that is learning rate. Okay, then we will set our gamma equal to 0.9, that is our discount factor. Then we have epsilon, which is our exploration rate. Okay, and then we will initialize our Q table. Okay, Q will be np dot zeros, env dot observation state is dot n, v dot action space dot n. Okay, so we have initialized our Q. Okay, now we have to initialize the function to choose action using epsilon greedy strategy. Okay, so def choose action will pass the state if np dot random dot uniform less than epsilon, then explode the random action. Okay, and if it is false, choose action with highest Q value. Return action. Okay, now we will create a function that will update our Q table. Okay, so function to update Q table. Okay, def update Q. Okay, state reward next state comma next action. Okay, so here we will update that. So we'll take the Q table where the particular state comma action plus equal to alpha into reward plus gamma q. Subtracted with okay, wait, here it should be in list. Okay, so we are done with this part, and seems there is a parenthesis error. So here no any parenthesis is required. Okay, and we will go to the training part where we will define number of episodes. So let's say number of episodes are 10,000. Okay, we will have reward list which is empty list. So for I in range of n episodes. Okay, first we will reset environment and get initial state. So state equal to env dot reset. So some of the part you will see that they are similar to most of the algorithm. Okay, so it is a advantage that we just have to change the actual formula, and mostly the rest of the thing it will be same as it is. Okay, so after resetting the state, what we do is we keep the done equal to false, total rewards 0, and we will choose the first action. Okay, action equal to choose action, and we'll pass the state. Okay, and then we'll loop over time step within one episode. So loop over time steps within one episode. While not done, we'll take an action and observe the next state and revert. Okay, so take an action and observe next state and reward. Okay, so next state comma done comma env dot step will pass that action that we have achieved in the previous line here. And next what we will do, choose the next action using epsilon greedy strategy. Okay, so here we will take next action equal to choose action. We will update the q value table, I mean. Okay, so we'll call the update q, and we'll pass state action reward, next state and next action. Okay, and we'll change our state. I mean the old state will become new state. Okay, and our action will become next action, and we will update our total rewards. And finally we will append it to our episode. Okay, the total reward list. So it will be reward list dot append total reward. Okay, and now we will plot our cumulative reward that we have achieved, or the agent has achieved it, not me. Okay, so let's plot them. So plt dot bar plot and p dot arrange episodes comma reward list. Okay, and plt dot x label episode y label cumulative reward and plt dot show. Okay, we have a error in else section. Where is that else? Is it this one? Okay, line number 16. Yes, this one. Okay, there is a star. Okay, it's running, I think. Okay, arrange. Where is that actually? 54 line. Okay, it should be arrange, not arrange. So it is running. Okay, we have the output. Now you can see. So same. I mean the output is obviously almost same that we have seen for the um, temporal difference algorithm, but here the output that you see is that even after so much learning, in some places the reward cumulative reward is 0, right? I mean so basically what we will convey, so the output of this code is like so I mean the plot shows that the agent I mean no, initially has very low score, but over time the performance increases, but sometime you can see that even after learning so much, the reward is close to 0. Okay, so it's gradually learning to navigate the environment to achieve the goal, but sometime you know I mean it not even learning. Okay, so that time what you can do is you can even explore with the alpha value. So let's say from 0.1 I'm setting the alpha value to, okay, not this one, I was basically referring to epsilon. Okay, so let's change the epsilon value to 0.7 and see how it is you know uh, affecting our learning. Okay, and also you can even trace how basically what all action our agent is taking by typing env.render. Okay, it will show you the output. Okay, not here, env.render. Okay, So we'll go more into details of env render when we actually start the project part, since it is just examples, how to implement such algorithm. So that's why I'm not getting into env.render, because it will also help us record a video of agent playing the game. Okay, so we'll see that later in the later part. So now you can see, even when we increase the epsilon, it it haven't learned anything. Okay, you can see that sometime it is performing some actions which is to reach the optimal goal, but majorly 99% of time, I mean, this algorithm is not learning. That's why we always set our epsilon to 0 0.1, and you can set to 0.05 as well. Okay, so let's see at 0.05 level how how the learning progresses. Okay, so let's run it and see. Okay, and now you can see that after I make the environment dot render equal to true. So basically this is making the render equal to true, and you can see the output at what position my agent is taking, left, right, top, down. So mostly you can see that my agent is taking left, 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 mostly left. We hardly see right and left and down. Okay, so that's the reason, the performance is very low. You can see that this time, it not even perform any, not even learn anything. Okay, so make this 0 0.01. Okay, okay, 0 0.1, and let's see the last output. So this is how you basically work with the gym environment. Okay, so next what we will learn about um, some neural networks part. Okay, how we basically implement and what is the need of deep reinforcement learning. So after this, only thing comes is deep reinforcement learning algorithms, which is 2 or 3. Okay, and we'll learn in the next video what basically and why basically we need neural networks to solve RL problems. Okay, so you can see that, okay, we have to restart our kernel and then you know perform this action, because now every time we are running it, we are getting cumulative reward 0. So I think we have to make our render false to see it the output very fast. Okay, gym is not defined. Okay, okay, why is this happening? Okay, let's make it gamma equal to 0.99, epsilon equal to 0.5. Okay, now it will show some output, but let's see what how the learning is going on. Okay, so it had made some progress, now you can see. Okay, so let's learn why neural network is required in reinforcement learning. Okay, in the next video we'll see.